concepts. You're welcome once again to my channel. So we want to continue this revision class. We are going to be revising Chem 101 and we want to continue from where we stopped. So last night we continued with Chem 101 revision and we were able to handle chemical kinetics. This is what we did last night and this was the last question we solved. Now, a lot of students have the course outline, but because of mix of names, they don't understand the difference in topics. So, and I was able to highlight this on the WhatsApp group. So if you check the course outline that was posted on the WhatsApp group, you'll notice in the course outline, what they did in that course outline is that they compressed a lot of topics. They wrote a lot of topics together on the same line. So you would see where you have rate of reaction. Rate of reaction is actually studied in chemical kinetics, just like we studied. We talked about chemical kinetics, talking about how fast or the time rate at which a reaction attains equilibrium. So that is chemical kinetics. So it means chemical kinetics studies the rate of a reaction. So you should understand that in your course outline where you have rate of reaction, it's talking about chemical kinetics. So in case you are not aware, so you need to be aware now. Go back, rewatch that video. You will notice that just the topic on chemical kinetics took us 2 complete hours to handle it. So to tell you how big the topic is, and I even tried to summarize it, even though I didn't even exhaust everything there. I just tried to cover the areas that are necessary for you. So it's a topic I would suggest you go back, rewatch that video. Remember, your exam is tomorrow. So I don't know what else you should be doing other than revising. So if you are present in this class, we want to move with speed. Quickly register your presence by dropping a comment and present. Register your presence, hit the like button. Now, what I want you to do for me is I want you to share this video. Share it in your class group. I usually say this, but most times you don't do it. Share it, then come back. Let us start. Please share the video, then come back so that we can start, so that every other person will be aware. Share it. If you have a class group, share this video to that class group. Tell them to come and join Chem 101 free revision class. It is free. All you need to participate is your data. So it's a free class and it's a class that is elaborate. Usually people pay just to join this kind of classes, but it is free. And I want you to share, hit the like button so we can start. Let me see those present. We have 19 persons. To share, invite us. This early morning class was supposed to have up to 100, 200 students. So hit the like button, hit the like button, hit the like button. Tochi green light is here. Faith is here. You're welcome. Ebus is here. You're welcome. Chineche Charles, you're welcome. You're still asking if it has started. We're just about to start. Okay. Muna, you're welcome. Mesoma Ugu, you're welcome. Muna, you're welcome. Uchechi, you are welcome. Hope, Arise Media, you're welcome. Immaculate, you're welcome. Chuku the Judith, you're welcome. Becky, you're welcome. Benedict, you're welcome. So quickly hit the like button as you're joining us. Hit the like button, hit the like so you don't forget. Hit the like. So if you're yet to subscribe to this channel, so we have a series. Now, I need you to understand that Chem 101, like I've always told you, it's actually made of 2 parts now. Chem 101 is 2 parts that you need to understand. One part of it is actually Chem 101 is divided into 2 parts currently. Previously, Chem 101 used to be 1 part. So Chem 101 is like 2 courses in one currently. So I wonder what you'll be doing if you are not prepared. The topics are too much to finish studying in one day. So Chem 101 is 1, inorganic chemistry. So one part of it is inorganic chemistry, the other part of it is physical chemistry. So these are the two parts of Chem 101 you need to know. Under the inorganic chemistry is where we'll talk about atoms, we talk about molecules, you talk about elements, you talk about history of atom, you talk about electronic configuration, you talk about quantum numbers, you talk about periodic table, you talk about chemical bonding. These are the things we'll be studying under the inorganic part. You talk about stoichiometry, right? Now, then when you come to the physical chemistry part, which is the part I'm focusing on now, you have your chemical kinetics, which is what you know as rate of reaction. You have your chemical equilibrium, you have your thermodynamics, which is big, chemistry, right? You have your thermochemistry, you have your redox reaction, you have your acid, base, and salt, you have your electrochemistry. These are the parts you have under physical chemistry. You also have your gas laws, you have your kinetic theory of matter. You see, this is too big. So I wonder what you'll be doing if you are not joining this class. So these are the two areas of Chem 101. So I have some videos that have been uploaded on this channel already. I've done live session, 2 live sessions, in fact 3. This will be the 4th live session on Chem 101. If you go to my channel, just click live, you would see Chem 101 videos. I've made videos on a good number of topics under this, for which if you want me to repeat, especially stoichiometry, chemical bonding, I would repeat. So in case you want me to repeat stoichiometry and chemical bonding under this, you drop it in the comment section, I'll repeat. So for now, I'm trying to handle the topics here. I've touched chemical kinetics, which is rate of reaction, right? So I want to get into redox reaction now, look at chemical equilibrium, look at acid, base, and salt, right? So that session, I would also look at other parts. So that is what we want to do. Thank this morning, we should have enough time to handle these things. So if you understand what I've explained, tell me to move on. If you understand what I've explained so far, you tell me to move. That Chem 101 course nature is clear to you now. The nature of Chem 101 is clear to you. Okay, Esther said just chemical bonding. So that is the only one you want me to repeat there. Okay. So, and I think, okay, bonding only. Thank you. So, okay, I should move on now. All right. So we're going to look at redox reaction. We're going to consider and we're going to summarize it very fast. Redox reaction. Of course, when you see the word redox, it comes from 2 words. One of them is reduction, and the other one is what? Oxidation. So what is a redox reaction? A redox reaction is a reaction that involves the transfer and acceptance of electron. That is a redox reaction. It's a reaction where being transferred. That is the redox reaction, or a reaction that involves a change in oxidation state. So what is a redox reaction? It's a combination of 2 kinds of reaction. One of them is reduction, the other one is oxidation. So a redox reaction is a reaction that involves the change in oxidation state. So in a redox reaction, electrons are being what? Transferred. Electrons are being what? Transferred. So anytime you see a reaction where there is no change in oxidation state, it simply tells you that electrons are not being transferred. And that kind of reaction is not a redox reaction. So in this video, we're going to be learning the types of redox reaction we have. We're going to be learning the reactions that are not redox reaction. We're going to look at redox reaction. We're going to consider definition of redox reaction. We're going to consider oxidation state calculation, and that is where I'm going to start from, so that it will now lead us to definition of redox and oxidation and reduction and oxidation reaction. So very quickly, we want to learn oxidation state. Oxidation calculation. So this is like the easiest part of this. So we're going to start from here. Now, there are three terms that students usually mix when you come to oxidation calculation. What are those three terms? And I want to clearly explain those three terms. One of them is oxidation number or state, oxidation state, however you want to call it. That is one of them you need to know before you'll be able to do oxidation calculation. You need to understand oxidation number or oxidation state. Oxidation number you're going to see is a rule. Then, number two thing students usually mix is valency. Valency. Now, a lot of students also even think that valency is also the same as what? Valence electron. So these three concepts are different, even though they may look similar, but they are what? Different. And right now, I believe some of you might be wondering, wow, I was thinking these things are the same, but they are not the same. So what is oxidation number, or what is oxidation state? Oxidation number is the charge that is assigned to an element, assuming that it is in an ionic state. Oxidation number is the charge that is assigned to an element in its ionic form. It is the charge assigned to an atom in its what? Ionic form. That is oxidation number. So it means that oxidation number can either be positive or it can either be what? Negative. That is oxidation number. And you can actually get most oxidation numbers, you can get them from valency. You can get most oxidation numbers from valency or even from valence electron. So before we look at valency and valence electron, I'm still talking about oxidation number, right? Now, what are the rules in oxidation number assigning? So there are rules that help us to assign oxidation number. One of those rules is that free elements have an oxidation number or oxidation state of 0. Free elements have oxidation state, OS, oxidation state of 0. Right? Free elements. What do we mean by free element? Something zinc. When you just see zinc, is a free element, right? But when you see something like, is this a free element? No. This is combined. So this is a compound. It's not a free element. But when you see something like just zinc, is it a free element? Yes. When you see a metal, any metal you see standing on its own without any charge, that metal is a free element. If you see something like zinc 2+, is this a free element? No, this is an ion. So it's not a free element. All right? So free elements have oxidation state of 0. So if I ask you what is the oxidation state of zinc, in this case now, you will tell me it is what? 0. All metals that stand on their own have oxidation state of 0. Sodium, then all elements, right? Yes, so you have oxygen, O2. This is an element of oxygen, or you say a molecule of oxygen. What is the oxidation state? It is a free element, so the oxidation state is 0. I hope that is clear to you. If you see something like this, H2, is it a free element? Yes. What is the oxidation state? 0. Same thing and so on. If you have iron, is it a free element? Yes. So the oxidation state of free element is 0. This would help us, especially when we also get to balancing of redox reaction. So that is one rule. Number 2, oxidation state, OS, oxidation state of oxygen is -2. Oxidation state of oxygen is what? -2, except for peroxides. Where it is -1. So we are saying that the oxidation state of oxygen in most compounds is -2, except in peroxides such as that the oxidation state of hydrogen, this hydrogen peroxide, the oxidation state of oxygen in this compound is -1. Apart from peroxide, you can have hydrogen peroxide, sodium peroxide, and so on. Apart from peroxide, the oxidation state of oxygen is always going to be what? -2. So it's like H2O. Which, when I ask you what's the oxidation state of oxygen in this place, it should be what? -2. It should be what? -2. Now, you have, I want to rub this part, but I'll be explaining. I'm still in number 1. So you have this and so many other compounds. Say you have sodium oxide. You have this. What would be the oxidation state of oxygen in this case? It is what? You are correct. It's going to be -2. Why? Because oxidation state of oxygen is always -2, except for peroxides. Is that clear to you? Yes, in peroxide, it is -1. So take note of that. Now, number 3, you should understand is that oxidation state of hydrogen is what? +1. The oxidation state of hydrogen is +1, except in metal hydrides, where it is -1. So the oxidation state of hydrogen in most compounds is always going to be +1, except in metal hydride. An example of metal hydride is sodium hydride. So in sodium hydride, the oxidation state of hydrogen is -1. So in most metallic hydrides, it is -1. So you won't be meeting this most of the times. So you will notice that the oxidation state of hydrogen will be considered to be +1 in most of our cases. Now, these are basic rules you should understand. Let me add number 4 for group 1. Group 1 in the periodic table. Group 1, elements such as potassium, sodium. So for group 1 element, lithium, their oxidation state is +1. For group 2, the oxidation state is what? Is +2, and so on. So this is what you should understand. For metals, the oxidation state is usually plus. Then group 3, an example, group 3, for which our major example there is aluminium. The oxidation state is +3. So take note of these rules in oxidation state calculation. All right? Yes, that is oxidation number. Please, if I can rub this, say move on, so that I can move on. You're following me, say move on. So we are moving on. Let's forget about those ones for now. We are still moving on. We have to finish before we talk about old topics. All right? So, all right. So that is oxidation state that you need to understand, and I've given you the rules. What about valency? What do we mean by valency? What do we mean by valency? Valency is simply the valency of an element tells you the number of bonds that that element can form. Valency describes the number of bonds an element can form, or it describes the number of electrons an element is willing to give out, that is to say lose, or willing to accept, so that it will be what? Stable. Valency of an element describes or decides the number of bonds an element would have. This thing is especially very important when we start talking about chemical bonding. So the valency of an element tells you the number of bonds an element can form. It also tells you the number of electrons an element is willing to transfer or accept, so that it can attain stability. The reason why elements lose electron or accept electron is so that they can be what? Stable. So that is valency. For example, and one of the things you should know about valency is that valency is always positive. Oxidation number can be positive or negative, but valency is always what? Positive. For example, if you have sodium, let us of sodium. Sodium is going to be 1s2. Sodium is number 11. 1s2, 2s2, 2p6, this is 10, and 3s1. This is sodium. Now, what is the outermost shell in this case, or the outermost orbital in this case? It is 3s. That is the outermost shell you have here, right? It is 3s. Now, assuming we don't have anything like this, say this is where we end, and they ask you what is the outermost shell in this case, you're not going to say 2p. It's not necessarily the last one alone. You're not going to say 2p. The outermost in this case is going to be 2p and 2s. As long as their coefficients are the same, then both of them becomes the outermost. But in the case of sodium, we have 3s1. So it means that our valence shell or outermost shell is the 3s, is the what? 3s. Now, what is the electron on that valence shell? It is what? 1. So it means that sodium will not be stable because it has 1 electron. In every outermost shell, every element like to have 8 electrons. Wow. Our network stopped. Wow. Hey. My God. Please, where did the network stop? I just came and noticed that the network stopped connecting. Please, at what point? At what point did it stop? So I will know what to. Can you quickly tell me? Oh my God. Can somebody tell me when you stopped following? Can somebody tell me when you stopped following? If you really got all what I explained. Can you tell me the point where you stopped so that I will know what to re-explain? Nobody is typing yet. I'm still waiting. Can you tell me when the network affected you so that I will know what to re-explain? Because I'm already done explaining this and I just noticed the network went off. Okay. So, okay. Say from valency of sodium. You were talking about valency. So it means I should re-explain valency, right? Okay, let me re-explain that. All right, very quickly. My God. I've already been explaining, I've explained quite a number of things without knowing that I was disconnected. And this is some of the challenge we face when we are recording videos. You record and you keep talking, and when you go and check, you notice that stopped recording. It becomes a double work for you. Now, I was explaining the difference between valency oxidation state, and valence electron. So, and I used sodium to explain. Now let me use, I already used oxygen and even chlorine to explain it. So let me still re-explain these three things. I've already talked about oxidation state. Now, for example, say you have oxygen, which is number 8. I want to determine these three things. Now, oxygen, I'll write the configuration as 1s2, 2s2, 2p4. This is oxygen, which has 8 electrons, right? Yes. Now, looking at this, what is the valence shell? Remember, valence shell is the outermost shell. And when you look at the outermost and it has same coefficient as the one preceding it, it means both of them are your valence shell. So in oxygen, this becomes our valence shell, right? Now, what is valency? Valency are the number of electrons an element or an atom is willing to lose or to accept so that it can attain octet or stability. If you look at this, most elements, with exception to those in group 1, in period 1 rather, most elements like to get 8 electrons in their outermost shell. So if you look at oxygen, which is one of those elements, oxygen has how many in the outermost? 2 plus 4, which is 6. It means oxygen would like to accept how many more? It would like to accept 2 so that it can become 8. The number of electrons oxygen is willing to accept is the valency of oxygen. So the valency of oxygen is 2. It is willing to accept how many electrons? 2. That is the valence of oxygen. State of oxygen. The oxidation state is the charge. Remember, when you are accepting, it is minus. When you are losing, it is what? Plus. Since oxygen is willing to accept 2, it means that the oxidation state of oxygen will be -2. The minus tells you that you are what? Accepting. Remember, valency is always positive. Oxidation state can be positive or what? Negative. Now, what about valence electron? What about valence electron? Valence electron are the number of electrons in the outermost shell. So, if you look at the outermost plus 4 is 6. So it means that the valence electron of oxygen is what? 6. Is it clear? Let me check again to be sure it has not cut. Is this concept clear? If it is clear to you, tell me to move on. But I want you to get for me the valency, the oxidation state, and valence electron of chlorine. Drop the answer in the comment section, please. All right, I'm waiting. I've given you a problem, right? I'm waiting. You're still saying move on. Okay, that is okay. Uchechi said I want you to give me the 3 answers. What I want to get for chlorine, I want you to tell me the valency of chlorine, if you understand what I explained there. Give me the oxidation state of chlorine. Give me the valence electron of chlorine. That's what I want you to give me. So let me see who has the answer. Okay. You write your answers in one line so I will know. So, but I think I should solve now. Now, first, let's write the configuration of chlorine, which is 1s2, 2s2, 2p6, 3s2, and then 3p5. That is the configuration of chlorine. Now, what is the outermost shell? The outermost shell is the 3s and 3p. That's the outermost shell. What is the valency? If you look at the outermost shell, you have 2 plus 5, which is 7. It means it needs 1 more to be complete. So the valency is 1. What is the oxidation state? The oxidation state is -1. Minus because it is accepting. Then what is the valence electron? The valence electron are the electrons in the outermost shell. So which is 2 plus 5, which is what? 7. I believe that this is very clear to you now. We want to look at the calculation of oxidation states. Can I rub this now? Can I rub now? So if it is clear, say move on. If it's clear, say move on quickly. It's clear. So I will need to be checking this constantly to be sure that network has not altered what we are doing. So, okay, yes. Chineche, Charles, I love your answer. You got it. I love the arrangement. So move on. All right. Now, we want to look at oxidation state calculation. Now, remember, that is what we're talking about. What we need is oxidation state. That is what we're talking about. And I've given you rules in oxidation state. Now, when you want to calculate oxidation state of an element, in a compound, what you do is you add up all the oxidation state and equate to the charge on that compound. If you have a compound like this, H2SO4, you want to find oxidation state of any element here. Say you want to find that of sulfur. It means you're going to add the oxidation state of hydrogen plus sulfur plus oxygen and equate it to the net charge. If there is no charge here, it means that the net charge is 0. So you're going to equate everything to 0. If you have something like this, HSO4 minus. Now, if you have this and you want to find oxidation state of sulfur in this, you add up this plus this plus this, equate it to what? -1. So let us take the first problem. I'll give you 3 problems and I'll move on. 1, find the oxidation state of sulfur in 1, H2SO4, 2, HSO4. So we want to find the oxidation state of sulfur in these 2 compounds. So I'll do the first one and I'll allow you to do the second one. So follow me. So now you would follow the rules I gave you. The oxidation state of hydrogen, I told you it is always what? +1. It is always what? +1, except for what? Metal hydrides. So the oxidation state of oxygen is always what? -2. So if you follow those rules, you'll be able to solve anytime. So how many hydrogen do you have here? You have 2 of it. So you say 2 times 1 for hydrogen plus the oxidation state of sulfur is what we are looking for. So I'll call it X plus. Now oxygen, how many oxygen do I have? I have 4. So I'll say 4 into, what is the oxidation state of oxygen? It is -2, just like we agreed. Now, once you sum all these things, you are going to equate to what? To 0, because there is no charge here. So you equate it to 0. To solving, you have 2 times 1, which is 2, plus X. This times this is -8 equals 0. You want to get X. So X becomes, when you push -8 to that side, it becomes +8. When you push 2, it becomes -2. Then X becomes what? 6. Because +6. That is your answer. So it means that the reason, if you want to name this, you say tetraoxosulfate 6. Tetraoxosulfate 6. So that's why you say sulfate 6. Now with this, I want you to solve for sulfur in this and drop your answer. 30 seconds quickly. Thank you, Uchechi. Thank you. Agatha, you're welcome. You're welcome. So who has done for the other one? I'm waiting. Okay, you say it's 7. Remember, if it's 7, is it +7 or -7? Oxidation state should carry a charge. Okay, Eze. Chineche says +6. Eze Sonto said is 6. Remember, oxidation state should either be positive or negative. Don't just say 6. All right, now let's solve it. So quickly, for this one, we are going to do the same thing. The oxidation state of hydrogen is 1, that is +1. Then plus that of sulfur, I'll call it X because that is what I'm looking for. Then +4 into the oxidation state of oxygen. Now, oxidation state of oxygen is not this, it is what you know. Oxidation state of oxygen is always -2, I told you. So I'll say into -2 and I will equate. The net charge of this whole thing is what? -1. So I will equate to -1. So what do I have? I have 1 plus X minus 8 equals -1. I have X equals -1. When this crosses, it becomes +8. When this crosses, it becomes -1. So when you add all these things, you have 8 minus 2, which is what? +6. So that's the answer. So those that said 6 are correct. One more, then I'll move on. Find oxidation state. Find oxidation state of carbon in C2O4 2-. Should I give you this? Okay, just do this. So quickly tell me the answer. So I'm waiting for your answers. Tochi Green, you say +6. Is it for this new one? So if you are just joining us, do well to hit the like button. Invite your friends. Tell them it is going. Some persons would have posted on the group that network. So go back and post that the class is on. All right? Chineche +3. Akochi Buna +1. Chukwudi +3. Chidebube +3. Olivia +3. Okay, let me solve. All right, success +3, Abus +3. So let me quickly solve. So we want to get the oxidation state of carbon. So, and I have how many atoms of carbon? I have 2 of them. So I'm going to say 2 times X because I don't know that X. And how many carbon do I have? I have 2. So I'll say 2 times X plus how many oxygen do I have? I have 4 of it. And what is the oxidation state of oxygen? It is -2. Notice it is not this -2. Naturally, oxygen has oxidation state of -2. Then you're going to equate to the net charge, which is what now? -2. That is the net charge. So you have 2x. This times this is -8 equals -2. You have 2x equals -2. When this crosses, it becomes +8. Then 2x is equal to 6. Then x becomes 6/2, which is +3. So this is our answer. And I believe that this concept is clear to you. So let's move on now to definition of oxidation and reduction reactions. We want to move to definitions. Can I move on? If you are done, say move on quickly. Say move on. I believe this is really very now. Say move on if we are good to go. If we are good, say move on, move on. All right. Chidebube, move on. Someone else, second it. This is like a meeting. Say move on if you are good. Move on. All right. So, remember we are studying redox reaction. So we want to look at definitions. Definition. Let us look at oxidation. We want to define oxidation. We're going to give 3 definitions of oxidation, but one is the most important, which is what I'm going to start with. What is an oxidation reaction? An oxidation reaction is a reaction that involves the loss of electron. It involves loss of electron. Oxidation reaction involves what? Loss of electron, and it leads to an increase in oxidation state. It leads to what? An increase in oxidation state. It involves the loss of electron and it gives rise to an increase in oxidation state. Let me give you an example. Say you have zinc, to give you zinc 2+. Say you have this. Now, if you look at this, you notice that this reaction is not balanced. So one of the things you should know about redox reaction is that whenever you want to balance redox reaction, you balance 2 things. You balance the number of atoms and you balance the charge. In your normal chemical reactions, you only balance atoms. But in redox reaction, you balance atom and charge. So if you look at this reaction, how many atoms of zinc do you have? You have 1 atom. The atoms are determined by the coefficient, the number you have or the number you have under here. The atoms are not determined by the number you have above. It is the number here or the number here that determines the atom. So somebody should not tell me that here you have 2 atoms of zinc. No, the atoms are determined by either what you have here or what you have here. So you can say 2 atoms of zinc in that reaction. That is for a reaction, even though atoms are strictly what you have here. Now, so that is what you have. So don't use 2 and say you have 2 atoms of zinc. What you have above represents charge. In redox, you are balancing atom and charge. So looking at this, you have 1 atom of zinc and 1 atom of zinc. So the atom is balanced. You want to balance the charge. You ask yourself, zinc on this side is a free element. Zinc in this side is a free element. What is the oxidation state of zinc in this case? It is what? 0, because it is a free element, right? Yes. Now, in this case, what is the oxidation state of zinc? You can clearly see it. It is what? +2. +2, right? Now, in order to balance this, remember, electron is usually negative. Electron is negative. Now, since this place is 0, I also want this place to be 0. So what I'm going to do to make this 0, I will add 2 electrons. Because I have +2, I will add 2 electrons. So it means this reaction will be balanced by saying +2 what? Electron. So that by the time you now add up all the charge, this is +2, this is +2 from zinc, and -2 from the electron. Then the charge on this side is 0. The charge here becomes what? 0. So it means that the equation is balanced. Now, please look up. Why is this an oxidation reaction? Remember, an oxidation reaction involves the loss of electron. Anytime you have electron on your right-hand side, it means you are losing electron. Anytime you have electron on your right-hand side, you are losing electron. If you have electron on your left-hand side, you are what? Gaining electron. So in this reaction, you have electron on your right-hand side. It means that it is an oxidation reaction, which involves the loss of what? Electron. It involves the what? Loss of electron. Is that clear to you? Yes. We also said that oxidation reaction leads to an increase in oxidation state. If you check, what is the oxidation state of zinc here? It is 0. And it increased from 0 to what? +2. So oxidation reaction involves loss of electron, and it also leads to an increase in oxidation state. In this case, from 0 to what? To +2. That is an increase. And I believe it is clear to you. Let me give you another example of an oxidation reaction. Another example, say you have iron to give you iron 3. Please, can somebody balance this for me? Balance this and tell me whether there is an increase in oxidation state or a decrease. Tell me from where it is decreasing or from where it is increasing. Drop the answer in 30 seconds. Thank you. Drop the answer in 30 seconds. Thank you. I'm waiting. Make sure you hit the like button. Share this video, please. Share it. Tell your friends to join. So I'm waiting for the answer. I'm waiting for the answer. Nobody. Okay, Chidebube, I love that. Thank you. Increased from 0 to +3. Thank you. From iron. Okay. Okay. Thank you. Thank you. Thank you. God's will. But that your answer is looking like AI. That is the way AI likes to write answer. God's will. Then Okorie. Thank you. Chineche Charles. Thank you. All right. So you are correct. So I believe the concept is clear. So you ask yourself, iron, is it a free element? Yes, the oxidation state is 0. Iron 3, is it a free element? No, the oxidation state is clearly written, which is +3. So it increases from 0 to +3. Obviously, when there is an increase in oxidation state, it means it's an oxidation reaction. It is what? An oxidation reaction. Is that clear to you? Yes. So where do you add electrons? Since you have +3 here, where you have higher number is where you add electron. And the electron you have is such that you should balance it on this side. So it means I should add 3 electrons here. So that is how that reaction should be balanced. So what I've just given you is one definition and the most important definition of oxidation. It is the most important definition of what? Oxidation. I hope that is clear to you. We can also define oxidation reaction as a reaction that involves the addition of oxygen. It involves addition addition of oxygen or removal of what? Hydrogen. So you can also define oxidation reaction as reaction that involves the addition of oxygen or the removal of hydrogen. An example would be, let's say you have magnesium plus oxygen. You are adding oxygen. So if you add oxygen to this, it will give you magnesium oxide. So just looking at this, you should know it's an oxidation reaction. Why? Because it involves addition of what? Oxygen. So oxygen is added to this. Is that clear to you? Which substance is oxidized in this particular reaction? Magnesium. Why? Because oxygen was added to magnesium. So magnesium is what? Oxidized. Magnesium is what? Oxidized. Is that clear? Yes. So this is an example where you have addition of oxygen. Now, say you have, for example, removal of hydrogen. Say you have C2H6, and this breaks down to give you C2H4 plus hydrogen gas. So plus hydrogen. Now you notice that in this case, you had how many hydrogen here? You had 6. In this case, you have how many now? 4. So 2 hydrogen have been removed. You now have this. So it means that this is also what? An oxidation reaction. This substance undergoes oxidation, or this substance is what? Oxidized. This substance is what? Oxidized. Is that clear to you now? Yes, so these are the 3 definitions. Let's look at reduction. Reduction. I'm almost done with this topic. I have like 2 more things to do. I'll go to the next topic. We have to be fast. So what is reduction? You can define reduction as what? The gain of electron. Reduction is gain of electron. It is gain of electron. And it leads to a decrease in oxidation state. Reduction is gain of electron, and it leads to a decrease in oxidation state, just like we explained for oxidation. Now, there is something you need to know that can help you remember this. I believe you know this already before now, or a rig, which simply tells you that oxidation is loss of electron, reduction is what? Gain of electron, or a rig. Oxidation is loss of electron, or oxidation involves loss of electron, reduction involves gain of electron. I believe this definition is clear to you. Now let me give you an example. Say you have copper Cu2 plus to give copper. Now, if I allow you to balance this for me, tell me where the oxidation state is coming from. This, balance this, give me where it is coming from quickly. You have to engage in this class. Tell me the answer. 30 seconds. 30 seconds. I'm waiting. God's will. You see, you didn't write with AI. I was only joking. All right. It just looks like that format. So, okay. Uchechi said from +2 to 0, +2 to 0. All right. And Chidebube gave us the reaction. Thank you. That's what I want to see. Chukwudi gave us the reaction. Thank you. So add +2 electrons. Thank you. So to balance this, you ask yourself, what is the oxidation state of copper here? It is +2. What is the oxidation state of copper here? It is what? 0. So you notice that it is decreasing from +2 to 0. So reduction leads to a decrease in what? Oxidation state. Is that clear? Yes. Now, since this place has higher number, it means this is where you will add electron. You add electron where you have higher number. So it means you're going to have Cu2 plus 2 electron to give Cu. And I told you that whenever you have electron on the left-hand side, it means you are gaining. It is accepting electron. So that's why I say reduction is gain of electron, because copper ion is accepting electron. Is this clear to you? Yes, it is clear. Now, you can also define reduction. You can also define reduction in terms of hydrogen and oxygen. So you can say reduction is removal of oxygen or addition of what? Hydrogen. So you can also define redox reaction in this way, in terms of removal of oxygen or what? Addition of hydrogen, right? Yes. Say you have nitrogen reacting with hydrogen to give you ammonia. So you notice that for nitrogen, hydrogen was added to nitrogen and it gave you this. Of course, you can balance it. This will be 2, then this will be 3, and it is balanced. So this is what now? In this case, what did you notice? Nitrogen is reduced. Nitrogen is what? Reduced, because hydrogen was added to it. Whenever there's addition of hydrogen to a substance, then that substance where hydrogen was added is what? Reduced. So nitrogen is what? Reduced. I hope this is clear to you. Addition of what? Hydrogen, or removal of what? Oxygen. Now, say you have, in a case where we have removal of oxygen, you can have, let's say, Cu copper 2 oxide plus what now? We'll remove this oxygen. Okay, let us say we have let's say we have this Cu plus hydrogen plus hydrogen. So let's see, this gives us Cu plus H2O. So if you have this, now you notice that, of course, I've not balanced, but if you have this, you notice that in this case, oxygen was removed from copper. Oxygen was removed to give you just copper, right? Yes, so this removal of oxygen, this substance where oxygen was removed from, has undergone what? Reduction. Or this substance is what? Reduced. So that is reduction in terms of removal of oxygen and addition of what? Hydrogen. So I believe that it is clear to you now. I believe it is clear to you now. So now, want to look at agents in redox reaction. There are certain agents that carry out this process. When you say a substance is oxidized or a substance is reduced, there is an agent that makes a substance to be oxidized or makes that substance to be what? Reduced. So those agents are what we know as agents of redox reaction. So if a substance is oxidized, it means there must be an oxidizing agent that made that substance to be what? Oxidized. If a substance is reduced, there must be a what? Reducing agent that made that substance to be what? Reduced. I hope this is clear to you. So one of them is what you call oxidizing agent. What is oxidizing agent? The agent that is responsible for oxidation. The agent that is responsible for what? Oxidation. So that is the oxidizing agent. Let me give you an example. Let me say I have this combination to give zinc 2 plus copper. Say I have this combination. I want to identify, in this case, I want to identify the oxidizing agent and maybe peradventure the reducing agent. So what would be the oxidizing agent? You would ask yourself, before you can identify oxidizing agent, ask yourself, which substance is oxidized? Which substance is what? oxidized. The substance that is oxidized is the substance where there is an increase in oxidation state. If you look at zinc, zinc moved from 0 to 2 to plus 2, right? Yes, it means that zinc is oxidized from 0 to 2. Zinc is oxidized. Who made zinc to be oxidized? It is copper ion. So it means that the oxidizing agent is copper 2 plus. The substance that is oxidized is zinc. The oxidizing agent is Cu2 plus. Did you get this explanation? The substance that is oxidized is this, okay? The substance oxidized is zinc, as the substance that undergoes oxidation or is oxidized is zinc. The oxidizing agent, which is the agent that brings about oxidation, is what? Cu2 plus. That is the oxidizing agent. Now, of course, you talk about number 2, which is reducing agent, which is actually the substance that brings about reduction. So for you to identify reducing agent, what do you need to do? You need to first identify the substance that is reduced. The substance that is what? Reduced. So what substance is reduced? If you look at this, remember the substance that is reduced usually have what? A decrease in oxidation state. So you'll notice that copper decreased from what? So the oxidation state of copper here is what? Plus 2. This is what now? It moved to what? To 0. So quickly tell me this answer. Which substance is reduced? Which substance is the reducing agent? So give me the answer to these two questions. Which is the reducing agent and which substance undergoes reduction or is reduced? Give me the answer very quickly. Let me see if it is clear to you. Hit the like button. We have 39, okay, 36 persons, right? I don't know why some persons are not here this early morning. Okay, the reducing agent is okay. Reducing agent is reduced. Okay, thank you, Chine Chechas. Copper is reduced. Copper 2 plus is what? Copper 2 plus is reduced. The reducing agent is what? Zinc. Okay. Thank you. Thank you. Thank you. Thank you. You are correct. So in this case, there's a reduction in oxidation state from plus 2 to this. This one, the oxidation state of this reduced. It reduced from 2 and became 0. So who is reduced? It is this, Abi. So copper 2 reduced. Now, who is the reducing agent? It is who? Zinc. The reducing agent is who? Zinc. So I hope it is clear to you. So this is what you need to know. I think I can rub this at this point. So let us now look at the last. Okay, want to now look at, before the last part, let's talk about types of redox reaction. Types of redox reaction. I will just name them. You're supposed to know types of redox reaction. You should know, so that when you see those type of reaction, you should know that they are all redox reaction. One of them is combination reaction. One of them is what? Combination. Of course, combination is a reaction where two elements combine to form a compound. Say you have iron combining with chlorine to form FCl3. Say you have this. Notice that this is a single element combining with another single element. So this is a combination reaction. Combination reactions are usually redox reaction. Number two, you should know is what? Displacement. Displacement reaction. Of course, we are dealing with single, which can still be called single replacement. Why are we specifying single replacement? We're talking about a displacement reaction where a single element is replaced. That kind of reaction is an example of a redox reaction. Now, say for example, you have zinc reacting with copper sulfate. If you have this is a single element. In this reaction, zinc can replace copper. You then have zinc sulfate plus what? Copper. So in this case, zinc replaced this. So this is a single element replacing another element. So it's a single replacement. It's also a displacement reaction. So this kind of reactions are what? Redox reaction. Number three is combustion. Combustion reaction, of course, are reactions where a substance is burning or reacting with oxygen. So they are also redox reactions. Say you have magnesium plus oxygen to give you magnesium oxide. So it's also an example of a redox reaction, right? Yes. Can we say, okay, let me add number four, very important, which you call disproportionation or disproportionate reaction. Disproportionate reaction. Disproportionate reaction is also an example of a redox reaction. What is a disproportionate reaction? It is a reaction where one substance undergoes both oxidation and reduction at the same time. It's a reaction where one substance will be oxidized and reduced at the same time. So an example you have in hydrogen peroxide. When hydrogen peroxide decomposes, it will give you water plus oxygen. So you can balance it. You balance 2 here, then you put 2 here. So I believe it's balanced. Now, if you look at this reaction, if you consider the oxidation state of oxygen in this case, what is the oxidation state of oxygen in this case? The oxidation state of oxygen here is -1, like we already know. We said the oxidation state of oxygen in peroxide is -1. That's the oxidation state of oxygen here. Now, what is the oxidation state of oxygen in water? It is -2. And what is the oxidation state of oxygen as an element? It is what? 0. Now, you will notice that when you compare this and this, you notice that the oxidation state of oxygen decreased from -1 to -2 is a decrease. I hope you know -2 is smaller than this. So when you compare these two, it is a decrease. When you compare these two, it is what? An increase. So you see that in this reaction, oxygen is both oxidized and what? Reduced at the same time. So any reaction where one substance undergoes oxidation and reduction at the same time is known as what? A disproportionate reaction. So I believe this is clear. These are the types of redox reactions you should know. Now, what are reactions that are not redox reactions? I believe I can rub this. Let me ask. Say move on if it is clear. Say move on if it is clear. My God. Okay, can I move on? Thank you. So these are types of redox reactions. So the reactions that are not redox that you should take note of is the reactions that are common, that are not redox reaction. One very common one is neutralization. Acid-base neutralization is not a redox reaction. Acid-base neutralization is not a redox reaction. Neutralization is not a redox reaction, right? That is one. Number two, that is not a redox reaction is precipitation. I believe you know an example of acid-base reaction. HCl plus sodium hydroxide is acid-base neutralization. So it's not a redox reaction. Precipitation reaction is not a redox reaction. What is precipitation? That's the concept you use in salt analysis. Precipitation is the process of bringing one substance out of solution. That's precipitation. Say you have something like AgNO3. AgNO3 is very soluble. If you want to bring out silver, and silver is connected to NO3, silver is very soluble. So it means you have to react this with something that can precipitate silver out of solution. So you can think of sodium chloride. Why did you think of a chloride? Because from Chem 107, you know that the chlorides of silver are insoluble. So when you combine these two things, what would actually happen is that you would have silver combining with chlorine or chloride, then sodium combining with this. So it's going to give you AgCl, which is now solid, plus NaNO3. So this solid, this is aqueous. This solid is the precipitate. This is your precipitate. So this kind of reaction is a precipitation reaction. How do you know? When they give you a reaction, just look out for the state. If one is solid and the other one is aqueous, know that it is a precipitation reaction. Where at the beginning, both of them are aqueous, but at the end, one is solid and the other one is aqueous. It means you have precipitated that. So precipitation reactions are not redox reaction. And finally, number 3, double decomposition. Decomposition reactions are not what? Redox reactions. So we want to quickly look at the last part of redox reactions. So into the next topic. The last part is balancing of redox reaction. I will give 2 examples and I'll be done. Balancing of redox reaction. I think I will just use an example to explain. I don't need to start giving you steps, but in case you want steps, I can give you. But if you want me to just use an example to explain it, tell me that I should use example. Balancing. We have done balancing in its simplest form. We want to look at more complex balancing, right? You want me to give you steps, or I should just take an example? Tell me in the comment section so that I will know quickly. Tell me quickly. Which one do you want? Example. So thank you. Somebody said, I thought we have the, who is that person? So I thought we also have the composition. Thank you. Is a very good one. The composition reaction. The composition reaction is actually a redox reaction. Thank you. The composition is a redox reaction. All right. Thank you for that. So, okay, I should just go straight to example. All right. With the example, you still get the steps. So that is just the thing. All right. So let's take an example. Say you have MnO4 minus plus Fe2 plus to give Mn2 plus Fe3 plus. Now say we have this and we want to balance. We want to balance this. The first thing you will notice is that you have 2 reactions here. You have the reduction half reaction, and the oxidation half reaction. So first thing you're going to do, I'm going to rub this board severally, so you have to be following me because it's long, right? So first thing you're going to do is to split this equation into 2 halves. So first, you know that I'm going to have Fe2 plus to give me what? Fe3 plus. So this is one of the equations, right? The next is I'm going to have MnO4 minus to give me manganese 2 ion. This is manganese 4. This is tetra of manganese, right? Manganese 7, I think. Now, if you have the where you actually have much work to do is the part of the reaction where you have oxygen. If I should even ask you, which of these two reactions is oxidation and which one is reduction? It's simple. The easy thing to do to identify the reduction and oxidation half reaction is I would prefer to use this place. It's very easy to identify this one. This one is more complex, but this one is easy. We can also identify this. If you look at the oxidation state here, it goes from 2 to 3. There's an increase. It means that this is the oxidation half reaction, and automatically this becomes the reduction half reaction. Do you understand me? If you look at this, it's in oxidation state increases, it means it is oxidation. If the oxidation state decreases, it is what? Reduction. So this oxidation half reaction, this is what? Reduction half reaction. In case you want to still know why this is reduction, if you do your calculation, you want to find the oxidation state of manganese, you do your calculation for this one. You want to know the oxidation state of manganese here, you're going to say X for manganese plus 4 into minus 2 for oxygen. Everything should be equal to minus 1. So you have X minus 8 equals minus 1. You have X equals 8 minus 1, which is what? 7. So what is the oxidation state of manganese in this place? It is plus 7. What's the oxidation state of manganese here? Is plus 2. So this one involves a decrease, while this one involves an increase. So this is what? Oxidation. This is reduction. And I believe it's clear, but this is not where we are going to. So let me rub it quickly. Now, we're trying to see how we can balance this equation, right? Now, we are doing our balancing. When you are balancing redox reaction, you can balance redox reaction in acidic medium or basic medium. Anytime you finish balancing your redox reaction and you have excess of hydrogen ion, it means that you have balanced that equation in what? Acidic medium, because it is acids that usually have that produce hydrogen ion. Anytime you finish balancing and you have excess of hydroxide ion, it means that you have balanced that reaction in what? Basic or alkaline medium. Is that clear to you? So our standard for balancing is acidic medium. Then I'll show you how to also balance in alkaline or basic medium. So let us do acidic. So now this is where we are going to work. First thing you want to do, once you split the equation into 2, the next thing, focus on that equation that has oxygen. Focus on that one first. Now, if you focus on the one that has oxygen, you balance the number of atoms. So if you check, how many atoms of manganese do I have here? It is 1. How many atoms of manganese do I have here? It is 1. So you balance the number of atoms without touching oxygen or hydrogen. Balance the number of atoms, but don't touch oxygen, don't touch hydrogen. So that's why I'm checking manganese is 1, manganese is 1. So it means that manganese is balanced. The next thing is you balance the number of oxygen atom. Balance the number of oxygen atom. How do you balance oxygen atom? By introducing water. You balance oxygen by introducing water to the opposite side. By introducing water where? To the opposite side. So I'm going to introduce water to this side. How many oxygen do I have? I have 4 oxygen. So I'm going to introduce 4 molecules of water. Why? Because I have 4 oxygen. So if you check, is oxygen balanced? Yes. Oxygen here is 4. Oxygen here is also 4. So it is balanced. The next step, since you introduce water, you have caused a problem. And what is that problem? You have brought in a new element, which is hydrogen. So the next step is to balance hydrogen. How do you balance hydrogen? By adding hydrogen ion on the opposite side. By adding what? Hydrogen ion on the opposite side. So it means on this side, I'm going to add hydrogen. So I have manganese plus hydrogen. How many hydrogen will I have? If you check, you have 2 times 4. You have 8 hydrogen. So I'm going to add 8 hydrogen here. So to give me manganese plus what? 4H2O. So this is what I have. I have balanced hydrogen, right? Then the next step, the next thing to do is to balance the charges. Balance the what? Charges. How do you balance the charges? You balance the charges by introducing electrons. So very quickly, let us check the total charge on this side. Manganese has a charge of minus, so you have -1 plus hydrogen has a charge of 8 times 1, which is plus 8. If you want to get the charge, the total charge of hydrogen is going to be what you have here times the coefficient. So it is 1 times 8, so it means hydrogen is plus 8. So the net charge on my left hand side is plus 7. Let us check the total charge. Remember, water does not have any charge, so it's 0. Manganese has 2, so the total charge here is plus 2. So you notice that the charges are not balanced. While this is plus 7, this is what? Plus 2. So the charges are not what? Balanced. So what am I going to do? I'm going to add electron to the side with high charge. I would add electron to the side with what? High charge. So what will I subtract from 7 to get 2? What will you subtract from 7 so that you can get 2? You're going to subtract 5. So it means I'll be adding 5 electrons to this side with high charge. So what am I going to have? I'll have manganese plus 8 hydrogen plus 5 electron to give me what? Manganese plus 4H2O. So I am done balancing this reaction. So I need to balance the oxidation. I need to balance this one now, the oxidation. So let me bring it here. I have F2 plus to give me Fe3 plus. I need to balance this. And I'm sure even you can balance this one, right? Because the atoms are balanced. You have one ion, but their charges are not balanced. So what do? You add the electron to where you have more charge. You have more charge here. So I'll add the electron. How many electrons will I add? I'll add 1 because I want it to be 2. So what will I subtract from 3 to give me 2? It is 1. So I'm going to say plus 1 electron. So that is what I have. I'm adding there. Now this is balanced. The charge of this is balanced. The last step is to combine this equation and this equation as one. In order for you to combine it, you need to make sure that the number of electrons in the two equations are the same. In this case, I have 5 electrons. In this case, I have 1 electron. It means I need to multiply this equation by 5. So if I multiply this equation by 5, or rather, let me tell you, what you usually do is multiply this equation by the number of electrons you have here and multiply this equation by the number of electrons you have here. So how many electrons do I have here? It is 1. So it means I'm going to multiply this one by 1. And if you multiply this by 1, it will still give you the same thing. Then I'm going to multiply this one by 5 because I have 5 electrons here. So this is going to give me 5 Fe2 plus to give 5 Fe3 plus to give 5 electrons. So once you have done that, you can now add the two equations. When you add the 2 equations, don't include electrons again. Don't write the electrons. So let me add equations. Now, when you are adding, you add all the left-hand side together and you add all the right-hand side together. So what is the left-hand side in this case? It is manganese, MnO4 minus plus 8H plus. Remember, when you are adding, you don't add electrons again. So plus, I don't need electrons. So I'll come to this place. What is the left-hand side? Plus 5Fe2 plus. I've added all the left-hand side, this and this. Then this would give me what now? I'll add all the right-hand side. I'll start from here. This would give me Mn2 plus what? Plus 4 H2O plus what now? 5Fe 3 plus. 3 plus. So I am done. Remember, I'm not adding the electron. So this is my final answer. It looks long. Yes. Is it simple? Yes. So if this is clear to you, say move on, and I'll give you one to solve by yourself. And we are done with redox reaction. Thank you. If it please tell me that it is clear. Let me give you one to solve. If it is clear, tell me. Is network still disturbing? Okay, move on, right? So I'll give you my exam. I'll give you your own classwork to do now. Okay, thank you. It's clear. I can rub it. So balance this for me. To balance this, I'm giving you 1 minute. I will allow you to do it actually so that you can practice. I'll give you 1 minute. Try to balance this and tell me your answer. I'm waiting actually, so just try to be working on it. I've given you a work. It's waiting on the board though. So I'm waiting for that answer so that you attempt it before I solve. I'm waiting. Thirty more seconds. Yes. I'm still saying move on, move on. I want you to solve. Attempt that question. If you attempt, that is the last. I'm done with redox reaction. I want to enter another topic. So, and I want you to solve this before I solve it. So that, remember, the exam is tomorrow. You don't have extra time to learn. So solve it. Solve it. Chineche said more time. So I'm giving you extra 30 seconds. Solve it. All right. Solve it. So that we can make I give oxidation state. That's not what we want. We want the balancing. All right. 15 more seconds. I think at this point I should solve. Yes. Right? I'm happy. Ako Chibunna, first person to produce answer. And this is your answer. This plus 14 hydrogen plus iodide, okay, to give chromium this plus water plus iodine 2. Okay, we're going to verify now. So I think with that answer I can solve. So the rest of you, I would like you to stop solving and watch me solve it, because this is the end of redox reaction. I think we have tried in summarizing. So you can see how big these topics are. Big. And I don't want to just do problem solving randomly without explaining topics. Please, I've explained. If you check the channel, go and check. I've explained chemical bonding. Please watch it. I've explained stoichiometry. Watch it. I've explained electronic configuration. Watch it. I've explained quantum number. Watch these things. So I've explained up to 8 topics now so far. 8 important topics. So follow me and let us solve this. First, we want to split this. We have I minus to give, that's iodide ion, to give this iodine gas. Then we have Cr2 chromate ion, this 2 minus to give what now? Cr3 plus. Now, I don't need to know which one is oxidation or reduction reaction, but it's simple to know. The iodine here is -1. Oxidation state is what? 0. There's an increase. Remember, negative is smaller than 0. So from -1 to 0 is an increase, which is oxidation half reaction. This is reduction half reaction. Now, I say when you want to balance, you start from where you have oxygen. So first thing to do is to balance the atoms without considering oxygen. Balance the what? Atoms. If you check here, you have your chromium and your chromium ion. Your chromium here is how many? 2. Your chromium here is how many? 1. So I need to balance this chromium by putting 2 behind. So I have balanced chromium. The next thing, once you have balanced your atom, you go on to balance oxygen. How do you balance oxygen? Introduce water to the opposite side. So I will take plus, how many oxygen do I have here? I have 7. So plus 7H2O. That's what you're going to do. Now, once you balance water, you have introduced a problem, which is hydrogen. So you need to balance hydrogen. How many hydrogen do you have here? 14. 2 times 7. So you need to balance hydrogen by introducing hydrogen ion to the opposite side. So I'm going to introduce 14 hydrogen ion here. So what do I have? I have 14H plus Cr2O7 2 minus. Somebody should remind me to do basic medium. I forgot, and I may still forget it, because what we're doing is acidic medium. So plus this, I've introduced hydrogen ion, which is 14. Then this will give me 2Cr3 plus 7H2O. So this is what you have. Now you have balanced hydrogen. The next thing you want to balance is your charge. How do you balance charge? By introducing electron to the side with more charges. Let's check our charges. Here you have 14 hydrogen, 14 minus 2. This is minus 2. So this is going to give you 12 plus 12. Let's check. Here you have 2 times 3. 2 times 3, which is plus 6. plus 6, right? So you see that here you have more charges. Now, what will you remove from 12 to give you 6? It is what? 6. So it means I will add 6 electrons to this side with more charges. So I have 14H plus chromium O7 2 minus plus 6 electron to this side. So give me 2 chromium 3 plus chromium ion plus 7H2O. So this is what I have. So I'm done balancing this. Now the next, I want to go back to balance this one. I need to balance this one. So let us write it. So you have iodide ion to give I2. So let's check. You need to balance the number of atoms. How many iodine do you have here? You have 2 atoms. How many do you have here? You have 1. So you need to place 2 here so that it will be balanced. Once you balance the atom, the next thing is to balance the charge. Now, what charge do you have? You have 2 times minus 1. So here is minus 2 and here is 0. So you need to balance the charge. Remember, this place is higher. 0 is bigger than minus 2. So it means you need to introduce how many electrons here? 2 electrons. So you have plus 2 electrons on that side. You have balanced this. Now the second to final step you need to take. I told you, multiply this equation by the number of electrons you have in this one. Then multiply this one by the number of electrons you have here. So it means I'm going to multiply everything here by what? By 6, because I have 6 electrons here. So if I multiply, this becomes 12I to give you what? 6I2 plus what? 12E minus, right? Yes. Then this particular equation, I'm going to multiply it by 2. So 2 times 14 is what? 28H plus 2 times this is 2Cr2 O7 2 minus plus 2 times this is 12 electrons. This would give me 2 times 2 is what? 4 chromium 3 plus 14H2O. So since you have done this, the last step is to combine these two equations. Remember, when you are combining, you combine the right hand side together, combine the left hand side together, combine the left hand, combine the right hand side, but don't include electron. So I'm going to have, if I combine these two, I'm going to have, let me start with this. I'm going to have 28H plus 2Cr2O7 2 minus plus 12 iodide ion. This would give me what now? 4Cr3 plus 14H2O plus what now? 6I2. That is this part. So this is my final answer. But if you like, you can still reduce it. You can divide all through this equation by 2. You can still reduce. If you divide this by 2, it becomes 14. Divide by 2, it will go. Divide by 2 is 6. Divide by 2 is 2. Divide by 2 is 7. Divide by 2 is 3. You can still reduce it by dividing, but this is our answer. So, and I believe this is clear to you, right? So I need you to screenshot. Then I'll show you how to balance in alkaline or basic medium. Screenshot it. If it is clear, say move on. I'll show you basic medium and we are done with redox reaction. So say move on if you need to move on. Okay. Chineche also gave me answer. Is your answer correct? 14 this 6 iodine, so it's not correct. Uchechi, is your own correct? Uchechi, your own is not complete. Chidiebube, is it correct? Chidiebube is not correct. Hope, is it correct? Hope is almost correct, but you missed it. Chukwudi, is it correct? It's not correct. So nobody got it. My God. Nobody got it. You are multiplying. That is iodine. Yeah, you have to balance atoms before you balance charge. That is BTS lover. You have to balance the atom. These two. For every balancing, first thing you balance is atom. And that is why when we started balancing this, I said these 2 atoms of chromium. I had to multiply this by 2 to balance chromium. The same thing, this is 2 atoms of iodine. I had to include 2 to balance it. So you first balance atom before charge. Now, this what we have done, because at the end of the day, now see what exam can ask you. They can give you reactions. They'll tell you which of these is present in acidic medium. Once you see hydrogen ion, it means that it is present in acidic medium. And if they want you to balance in alkaline or basic medium, it means that you're going to introduce OH. You're going to introduce what? OH minus. Now, what you do is that you're going to add OH to the 2 sides of the equation. How many OH will you add? The number of OH you would add is the number of hydrogen ion you have. So it means I would add 28 OH to the 2 sides. So if you do that, let me rub this side of the board. So you add OH, so you're going to watch. If you add OH to the right and to the left hand side, so we don't waste time, you're adding 28 OH to the 2 sides. See the idea. When you add 28 OH to the left hand side, OH will combine with hydrogen ion. So H and H will give you H2, then O. So if you have 28 and 28, this becomes 28 water. So it means on this side, I will just change it to 28 water. Then when you add OH to the right hand side, OH would remain. That is the idea. So can you permit me to go straight to the point, or you want me to write it? Let me just write it. So I have 28H plus 28 OH, right? Yes. Right? Now on this side, right? Now on this side, this 4Cr3 plus 14H2O plus 6 iodide iodine gas plus 28 OH minus. Now this is not your final answer because you cannot have water on the 2 sides. Now notice this side you have bigger water, which is 28. This side you have smaller water, which is 14. So you just say 28 minus 14. What will you give us? To give us 14. So this one will cross so that you have 28 minus 14. You now have only 14 on this side. So you then have 14 H2O plus 2Cr2O7 2 minus plus 12 iodide to give us what now? 4Cr3 plus 6 iodine gas plus 28 OH minus. So this is our final answer. This is our final answer. Now you notice that our final result we have OH. So it means that this is present in basic or alkaline medium. Screenshot it. Let me move to the next topic quickly. If you are ready, say move to the next topic. If you tell me you are tired, we'll end and wait for. Oh, network disrupted again. I don't know why network is misbehaving. My God, Chineke say you don't understand the basic medium. My God. Network. Hey, do you want me to re-explain it? My God. Wow. Do you want me to re-explain it? Now let me just give you a shortcut. Let me give you a shortcut. The thing, it took me time, a lot of writing. Okay, let me just explain. Let me give you a shortcut so that you don't waste time because your exam is OBJ. Can you see this? This answer is the answer we got. Can you see these two answers? This one is in basic medium. This one is in what? Acidic medium. Watch them. What are you observing in those two answers? I want you to find out what did you observe as the difference in the two answers. Check it very well. If you have checked it, you will realize that in this case, you have 28 hydrogen ion on the left hand side. Then on the right hand side, you have 14 water. But in your basic medium, on your left hand side, what do you now have? 14 water. On your right hand side, what do you now have? 28 hydroxide ion. That is just the idea. So if you have been able to do this, don't waste time following the process I've explained. Just interchange it. Your water, take it to the opposite side. Then your hydrogen, take it to the opposite side. Your hydrogen ion, take it to the opposite side, but make it OH. If what I have just said is clear enough, please tell me that it is clear. If it is clear enough this way, remember it's OBJ you are writing. You don't have to start doing all these things. I'll move on to the next topic quickly. It's clear. What I just explained, say it is clear. It is clear. Thank you. So now I want to move to another topic. So we want to quickly deal with acid. Acid, bases, and salt. Right? I'll be doing a summary so that let's see if we can finish in 30 minutes and call it at least a day for today. Right? Because I know some of you are tired. So acid, base, and salt. Now, what is an acid? An acid, we're going to start with acid. I'll be carrying both of them together. So what is an acid? Usually an acid, you would say on a general note, you would say an acid is a substance that contains hydrogen ion, right? On a general note. But what is the definition? An acid is defined as a substance that when you dissolve it in water would ionize to produce hydrogen ion. An acid is a substance that ionizes in water to produce what? Hydrogen ion. That is an acid. We will later learn different definition, but for now, that is the definition you started learning from with your in your secondary school. So an acid is a substance that dissolves or that ionizes in water to produce hydrogen ion. That is an acid. An example is HCl. When HCl, which is aqueous, which is already present in water, when HCl ionizes or dissociates, so what will it give you? It will give you H plus Cl minus. This is what you have. So when an acid dissociates in water to give hydrogen ion, when a substance dissociates in water or dissolves in water to give hydrogen ion, that substance is an acid. So this is the hydrogen ion. And I want you to know that hydrogen ion can also be called proton. Why do you call it proton? It's simple. You know that hydrogen normally has how many electrons? Hydrogen normally has one electron and one proton. Hydrogen has what? One electron and what? One proton. Hydrogen does not have neutron. I believe you are aware. So if you now have H plus, H plus, it means it has lost that single electron that it has. It has lost it. So the only particle that is left for this is just one proton. And that is why you usually call H plus a proton. You call it proton. But H is not a proton, it's just hydrogen atom. But this can be called hydrogen ion or what? Proton. So you'll be hearing us use that term, proton, for hydrogen ion. So that is an acid. You can still use water dissociation. You can still do this in presence of water, HCl plus water. When you directly dissolve it in water, this will give you, now what will happen here is that this H would come out and join with this H. It becomes H3O plus aqueous plus what? Now, if this H joins here, then you'll be left with Cl. You have Cl minus aqueous. So these two reactions are still saying the same thing. That is acid dissociation reaction. I believe this is very clear to you. That is an acid, right? Yes, and you have some properties of acid. Of course, there are different acids that you should know. In secondary school, you understand that you can classify acid into two. You can classify them as inorganic acids and what? Organic acid. Inorganic acid, you can still call them mineral acids. Then you have organic acids, yeah, right? Yes, usually all organic acids are weak acids. So you can have strong acid. You can also have weak acid, right? Yes, don't mix the word strong and concentrated. A strong acid can be concentrated, a strong acid can be dilute, a weak acid can be concentrated, a weak acid can be dilute. So strength of an acid is not dependent on the concentration, right? The strength of an acid is the extent to which that acid would dissociate or ionize in water. That is what determines the strength of an acid. Any acid that completely dissociates or that completely ionizes in water, that acid is a strong acid. So strong acid are acids that ionizes completely in water. That is to say, they give up all their hydrogen ion completely. Those kind of acids are strong acids. While weak acids are acids that don't ionize completely in water. I hope that is clear to you. Now, there are common examples of strong acid you should know. You should know that HNO3 is a strong acid. You should know that H2SO4 is a strong acid. You should know that HCl is a strong acid. You should know that HI, exam will ask you which of the following is not a strong acid. You should know that HBr, hydrobromic acid, is strong. These are the basic strong acid you have. HI is strong. Then HClO for perchlorate acid is a strong acid. So these are the strong acids you have. Now, some people would usually mix. Now, under weak acid, one of the major weak acids that they usually ask you in an exam is hydrofluoric acid. Because when you have seen hydrochloric, hydrobromic, hydroiodic, you might be tempted to think hydrofluoric is supposed to be here. Hydrofluoric is a weak acid. Then organic acids are weak acids such as ethanoic acid, methanoic acid, and so on. This is also a weak acid, and I believe that this is clear to you concerning the strength of an acid. What are some of the properties of acid you should know? These are common properties. One of the properties you should know for an acid, let me check my network to be sure it's still going. All right. So the properties, one of the properties you should know for an acid is that an acid usually have what? A sour taste. Acids have sour taste. One, sour taste. So this such as you can find in fruits like lemon. So you notice even orange, unripe orange, all these things are acidic. They have orange. What is the acid in orange? It is what? Citric acid, right? Yes. And so on. What is the acid in sour wine? It is what? vinegar. That is the wine they gave Jesus on the cross, vinegar or vinegar, depending on how you want to call it. But acids have sour taste, right? Yes, another thing you should know is that acids are corrosive. Acids are what? Corrosive. What does it mean? When you pour it on your skin would smile. Pour an acid on your skin, it will smile, right? Then you'd understand the meaning of corrosive. Of course, when you pour acid on your skin, it will burn you. That burning nature is what we call corrosive nature. Acids are corrosive. Number 3 you should know about acid is that the action on a litmus paper. An acid, like I told you in Chem 107, an acid will turn blue litmus paper, blue, to what? Red. Acid will turn blue litmus paper to red. So you should know. Another thing you should know for an acid is that acids usually react with metals. Acids react with metals. Metals above hydrogen. Acids react with metal above hydrogen in activity series to always liberate hydrogen gas. Acids react with metals that are above hydrogen, such as zinc, iron, aluminium, sodium, potassium. And acids would always react with those metals to liberate what? Hydrogen gas. These are some of the things you should know about it, and I believe it is clear to a great extent. And let me add number 5, the pH range. The pH range for acids are usually less than 7. The pH range of acids are usually less than 7. So if the pH of a substance is 6, it means that that substance is acidic. If the pH is 1, it is acidic. So the lower the pH, the higher or the stronger the acid. Right, sorry, the more concentrated the acid, right? So the pH range is usually below 7. That is for acids. Then you need to know what a base is. Base. You need to know what a base is, just like what I explained for acid. What is a base? A base is a substance that ionizes in water to produce hydroxide ion. Now, just to point out for you, this is called hydrogen ion, which is usually produced by acid, or this is produced by acid. This is called hydrogen ion, and this one is called hydrozonium ion. They are produced by acids, right? And a base is a substance that when it dissolves in water, it produces what? Hydroxide ion, OH minus, hydroxide ion, hydrozonium ion, or you can call it ozonium ion. Hydrozonium ion. So that is a base. That is a base. So very quickly, an example would be you have sodium hydroxide, which is a base. When this ionizes in water, it will give out to form sodium metal plus what? OH minus. So this is what you call a base. Any substance that would always is known as a what? Base. And I believe that this is clear to you. Also, there are things that you call examples of base. You have this. Whenever you see OH attached, you know it's a base. Now, something you call alkalis. What are alkalis? Alkalis are known as what? Soluble bases. Alkalis are what? Bases that are soluble, bases that can dissolve in water. Those are what we call alkali. And the major alkalis you have are sodium hydroxide, potassium hydroxide, ammonium hydroxide, which you can still call ammonia solution. Ammonium hydroxide. These are alkalis, that is soluble bases, are known as alkali, right? Yes. Then you also have other bases that are insoluble, such as calcium hydroxide and so on. They are insoluble. So these are the things you should know for bases. Now, what are the properties What are the properties you should know? And meanwhile, you should know that ammonium hydroxide is a weak base, but these ones are what? Strong bases. Ammonium hydroxide or even ammonia is a weak base. This is a weak base, but it is a soluble base. This one is a soluble base and is also a strong base. This is a soluble base and is also a what? Strong base. All the bases from group 1 elements of the periodic table are strong bases. The bases from group 1 are metals such as lithium, sodium, potassium. Their bases are strong bases. The bases from group 2, also calcium, they are also strong bases. But group 1, all of them are what? Soluble. So you call them alkali. That's why you even call them alkalis. Group 1 elements are called alkalis. Group 2 are called alkaline earth metals. So that's why you call them alkali. And what are properties of bases? I hope I'm not fast. Why I'm doing it this way is because this is a very simple topic, right? So I want to see how to summarize it fast so that I'll against the evening session. Now, properties of base. Let me check the network again. Thank you. Thank you. Thank you. So we are moving, right? Thank you. Now, what are the properties of bases you should know? Bases have bitter taste. They have bitter taste. Bases have what? Bitter taste. You know now it's bitter. Another one you should know is which is common. It has a soapy feel. That is to say, when you touch a base, it feels like when you are touching a soap. It's kind of slimy or soap. It has a soapy feel. These are two major properties you should know. Number 3, their action on litmus paper. Bases will turn red litmus to what? Blue. Bases will turn red litmus paper to what? Blue. So these are some of the things you should know about bases. There might be more properties, but these are common properties you should know about bases. Now, very quickly, we want to look at pH. We want to look at pH, or rather, before we look at pH, let us look at theories of acid and base. There are theories of acid and base before we now look at pH. What are the theories of acid and base? Now, there are so many people that gave us their own theories and explanations and definition of an acid and a base. But amongst them, we have 3 major theories that we are considering that explains what an acid is and what a base is. Now, what are those theories? We'll start from the first one. One of the theories, which is actually what I started with. The first theory is known as Arrhenius theory. Arrhenius what? Theory. According to Arrhenius defined an acid as a substance that would ionize in water to produce hydrogen ion. So Arrhenius, what are the highlights of his theory? One of them is that for him, water should always be involved, right? And then it should always produce what? Hydrogen ion. Those are 2 highlights for Arrhenius. An acid, according to him, is a substance that will dissolve or that will ionize in what? Water to produce hydrogen ion. So for him, 2 things he considered are water and hydrogen what? Ion. So Arrhenius acid is sufficient to be defined whenever water is involved. So according to him, if water is not involved, substances that can dissolve in some, ionize in some other substances are, according to him, are not qualified to be called acid. Substances that don't even need water, according to him, are not qualified to be called acid. For him, an acid is only those things that will dissolve in water and they will produce hydrogen what? Ion, which is a limitation already. So one of the limitations is that there are other substances that don't even need to dissolve in water, and those substances are what? Acids. For example, you have gases. you have CO2. CO2 behaves as an acid, right? Yes, but it does not even contain hydrogen ion, right? Yes, so CO2 is a gas, and so on. That is Arrhenius theory, which is actually what I explained to you as acid, and I'm using HCl. HCl dissolving in water to give you H3O plus Cl minus. So this is Arrhenius definition of an acid, a substance that dissolves in water and produces what? Hydrogen ion or hydrozonium ion. According to him, that substance is an acid. Then number 2 theory. Okay, that is for his acid. And his base, the same thing. According to him, a base is a substance that also ionizes in water to produce hydroxide ion. That is Arrhenius definition. So number 2 theory is Bronsted-Lowry. These are two different people that work, so that's why they are combining them. These are two separate scientists, but both of them gave the same idea. So they now named it Bronsted-Lowry theory. Now, what is their theory? Bronsted-Lowry, according to them, Bronsted-Lowry says an acid is a substance that donates a proton. It is a substance that donates a what? Proton. And what is that proton he's talking about? Hydrogen ion. So according to Bronsted-Lowry, acids are substances that can usually donate or give out hydrogen ion. So while, according to him, base is a substance that accepts a proton, which is actually hydrogen ion. So while acid gives out or donates, a base does what? Accepts a proton. That is Bronsted-Lowry. Let me give you a simple example. An example is this. You have HCl plus H2O to give you just what we said. Now, you would quickly notice that in this reaction, this substance, which is an acid, donates hydrogen. This hydrogen leaves. So this substance that is donating this hydrogen or this proton, this substance is your acid. Well, this one accepts the proton. Remember, this H was originally 2, but in this case it's 3. It means this one accepted the proton. This substance is your what? Base. So you now see that Bronsted-Lowry gave us expanded definition of acid and base. So according to Arrhenius, water is not actually a base, right? Yes, but according to Bronsted-Lowry now, we can now see that water is actually a base. And we are still going to see again that water can also be an acid. Water can be a base, water can also be an acid. According to who? Bronsted-Lowry. An acid donates hydrogen or proton while a base accepts. Let me give you another example. Say you have NH3, which is ammonia, plus hydrogen ion. Then you have this to give you NH4 plus. Can you see this reaction? Now you will notice that in this reaction, this ammonia is NH3, 3 hydrogen. But in this place, it became how many hydrogen? 4. It means that this accepted this proton. I hope you know this is a proton. This ammonia accepted this. So this one that is donating the proton, this is the what? Acid. That is the person that donated the proton. This young man accepted the proton. This is your what? Base. That is what Bronsted-Lowry is saying. So you would notice that according to Bronsted-Lowry, hydrogen ion is also an acid. But according to Arrhenius, hydrogen ion is not an acid. Acids are substances that usually contain hydrogen, according to him. That's why H2SO4 is an acid, because it contains hydrogen. Now, you will see the mistake he made. There are certain substances that contain hydrogen that are not acids, such as ammonia. Ammonia contains hydrogen, but is ammonia an acid? No. But he was claiming that any substance that contains hydrogen is supposed to be an acid. So that is another limitation of Arrhenius. Are you following what I'm explaining? If at this point you're following me, please say it's clear. Say it is clear. Let me check the network again. Are we on the same page? Are we on the same page? Only one person says it's clear. Are we on the same page? It's clear. Okay, 2 persons. I need more. Okay, thank you. So I can move on. So that is Lewis. I can give you more examples. Say you have, let's say you have HCO3 minus. Let's say this is reacting with OH minus. Now, if we combine this, we can have different products. One of the possible products is that this H will come and meet this. You now have 2H and 1O, which is now H2O plus CO3 2 minus. That is what you would have. When this H comes to meet this, you have H2O, then this will now be CO3 2 minus. That's carbonate ion. Carbonate is usually 2 minus. You should know that. So that's what you have. Now, if you look at this equation, who is donating this hydrogen tricarbonate is donating a proton, right? It donated proton to this. This one that accepts is your what? Base. So this is your what? Base. This one is your what? Acid, right? Yes. So that is Bronsted-Lowry's definition. Now, there is something called acid base conjugate. Acid base conjugate pairs, right? Yes, there's something that is called conjugate acid and what? A conjugate base. What is a conjugate base? Let's start with conjugate base. What is a conjugate base? It is very simple to know. A conjugate base is the substance that is left when an acid loses a proton. A conjugate base is the substance that is remaining when an acid loses a proton, while a conjugate acid is the substance that is formed when a base accepts a proton. Should I write it? Let me write it. Conjugate base is the substance remaining when an acid donates a proton. As a conjugate base, and I will explain with examples. What is a conjugate acid? Conjugate acid is the substance formed when a base accepts a proton. So let me quickly explain. Let me rub this side. So what do you have? Let me quickly explain. Starting from this first reaction, I'll give you maybe 2 more. Starting from this reaction, you've noticed that this young man is your acid. Why is it your acid? Because it donates a proton to this. When you remove this hydrogen from here, what will be left for this thing? It will be only Cl, this Cl. So it means this is your conjugate base. Cl minus is your what? Conjugate base. Now, what is your conjugate acid? Your conjugate acid, once you have known this, it means you should know that this is your conjugate acid. But what is your conjugate acid? The substance that is formed when a base accepts a proton. Remember, this is given to it. When you give hydrogen here, what is formed? H3. This becomes your conjugate acid. Is that very clear to you? Yes. Now, let us assume you have this particular reaction. So what do you have here? This is your acid, Abi. It gives out this to this, right? Yes, what is formed? What you have formed is this. So what is formed becomes your conjugate what? Acid. That becomes your conjugate acid. Now, if you look at this other reaction, you would notice that in this particular reaction, this acid loses this to this. So when you remove H, what is left? CO3. Remember, when you remove hydrogen, then what is left becomes your conjugate base. So when you remove this, you have CO3. This becomes your conjugate what? Base. This becomes your conjugate what? Acid, what is formed. I hope it is clear. Yes. What if I give you this? HCO3 minus plus OH minus to give us H2CO3 plus H2CO3 plus, sorry, that this will come. Okay. Plus oxygen. So, okay. Let's do it this way. Say you have this reacting with H plus. Let's say this is what you have. So if you have this reacting with this. Now, I want you to identify the conjugate acid and the conjugate base in this case. So I'm going. You have H sulfate minus. Let me see if it can go. This H2O. You have this H3O plus sulfate. You have this, and let's say you have HS this plus H2O to give you H2SO4 plus OH. Now, I want you to identify the acid, the base, the conjugate acid, the conjugate base, where applicable. All right? Do it quickly. I want to explain. My God, 20 persons. What is happening? Are you tired? Are we together? Some people are really talking of Lewis, and we're still talking of Brunstead Lorry. It's one after the other now. So let me just explain these examples and move on. So looking at this first one, you'll notice that this hydrogen is added to this to become H2. So this is your what? Acid. This is your what? Base. This is your what? Base. And when a base accepts a proton, what is formed becomes your conjugate acid. Conjugate what? Acid. If you look at this one, you would see that in this case, this substance loses this proton, right? This one is losing in this case. And this substance that is given is your what? Acid. This one is accepting is your what? Base. Now, when an acid loses, what is formed becomes the conjugate base. So this is your conjugate base. Automatically, this is your conjugate acid. And if you look at this last part, you notice that in this case, this one donates hydrogen to this. This one donates. This one that is donating is your acid. This one is your what? Base. And this one that accepted, your base, will now form your conjugate acid. This becomes your conjugate base. I believe this is very clear to you. Yes. Now, again, if you look at these things, you would notice that in this first reaction, this substance, hydrogen sulfate, behaved like an acid. In this place, it behaved like a base. In this place, this one behaved like a base. In this place, it behaved like an acid. In this place, this hydrogen carbonate behaved like a base. In this place, it behaved like an acid. Now, that can behave like both an acid and a base. Those substances are known as amphiprotic substances. They are known as what? Amphiprotic substances. So it means that hydrogen carbonate ion, hydrogen sulfate ion, water, they are all examples of what? Amphiprotic substances. Now, remember we're looking at theories of acid and base. Then the third theory is what you call Lewis theory. The third theory is what you call what? Lewis theory. Lewis what? Theory. Lewis what? Theory. Lewis. Lewis theory. Now, what, according to Lewis, what is an acid? According to Lewis, acid is an electron pair acceptor. It is an electron pair what? Acceptor. Electron pair means two electrons. So according to Lewis, an acid is an electron pair acceptor. Now, this Lewis you're seeing is the same Lewis that gave us Lewis structure in chemical bonding. So it means for you to understand Lewis acid and base very well, you need to know how to draw Lewis structure of different substances, right? So that is one of the things you should know. And according to Lewis again, a base is an electron pair donor. As a base, an electron pair what? Donor. Any substance that always wants to collect electron, those substances are said to be what? Electrophiles. So according to Lewis, Lewis acids are what? Electrophilic in nature. Lewis acids are what? Electrophilic in nature. They are electrophilic in nature. Because electrophilic means electron seeking, things that always want to get electron. While a base, a substance that wants to push out electron, according to Lewis, any substance that wants to give out electron, they are known as what? Nucleophile. So Lewis base are what? Nucleophilic. Nucleophilic in nature. I hope that is clear to you. Yes. Now, what is an example of Lewis acid and base? A common example you would always see. Any substance that is electron deficient is a Lewis acid. Any substance that is electron rich is a Lewis base. For example, you have ammonia, NH3. How do you know that ammonia is electron rich or electron deficient? You will need to know how to draw the Lewis structure. So that I will show you. To draw the Lewis, I've taught you Lewis structure. Go to my video, see under Chem 101 live session. You see Chem 101. Study under chemical bonding. You will see it. So the Lewis structure of this is N, H, H, H. Then you have two lone pair. So these electrons are called bonding electrons or bonding pairs. This one that does not connect to any substance is a lone pair. So ammonia is electron rich because it has extra electrons that are not participating in chemical bonding. So it means ammonia is an electron rich substance, right? Now, so meaning that ammonia is a Lewis base. Now you have another substance which is boron trifluoride, BF3, boron trifluoride. It is an example of a Lewis acid. It's an example of Lewis what? Acid. Why? Because it is electron deficient. Let us see. you draw the Lewis structure of boron trifluoride, you would have this. You would have this. You have this, right? Yes. Now remember, this central atom has how many electrons? 8. This is 1, 2, 3, 4, 5, 6, 7, 8. This central atom is supposed to have 8 electrons, but it has 1, 2, 3, 4, 5, 6. So it means it needs 2 more to be stable to attain octets. So what will happen is that this boron trifluoride would combine with ammonia and they will share this bond. So if I should put ammonia, this is my ammonia. This is your ammonia, right? If I'm to draw it this way. Of course, you know ammonia is now pyramidal. So if you are drawing it this way, and this ammonia would contribute this bond, it will bring it. It's not giving it out. It will bring it, and both of them will do what? Share it. Now, what kind of bond is present where one substance donate, or one substance is the one contributing, but both of them are sharing? That kind of bond is what you call dative bond. Is what you call what? Dative bond. So substances that are capable of going into dative bonding can actually form Lewis acid or what? Lewis base. So you should know that. So why this is a Lewis acid? Because it accepted the pair of electrons from ammonia. This that is given those pair of electrons is a Lewis what? Base. So this is one common example you would always meet. I believe this is very clear to you. Yes. So very quickly, I want to now look at pH, and that will be the end for acid, base, and salt. Now, of course, what a salt is, I'll just mention and give you the types of salt. So can I rub this now? Yes. Let me see. Thank you. Can I move on? Chisum, you said I should explain boron. Where is it? Yes, can you explain boron trifluoride again? Is it clear to you, or you still want me to explain it? Can I move on? Okay, I think I should move on. Everybody's saying you can. Thank you. So, now, so quickly, pH. What is pH? pH is actually a scale that you use to measure the strength of an acid or a base. pH is a scale that is used in measuring the strength of an acid or a what? Base. Is a scale of measurement, right? It's a scale, just like you have scale for measuring mass in grams, measuring mass in what? Kilogram is a scale for measuring mass. So pH is also a scale. pH measures the strength of an acid in what you know as logarithmic scale. It uses what? Logarithmic scale, right? And why is pH necessary? It is necessary because when you are dealing with concentration of acids or bases, most times you usually deal with very small values. You can have 0.001 concentration or molarity. So this is very small. So it will be difficult for you to compare. So they give you this, give you around 0.000. They ask you which of them is smaller. Most times, because you have so many zeros, you can't easily compare, right? So what does pH do? pH helps you to convert this thing to whole numbers, so that when you now see something like 2 and 4, whole numbers, like they ask you which of them is stronger, you can say it's 4. That is the essence of pH. So, and I believe that is clear to you. So now we're going to start with pH for strong acids. For strong acids slash base, because we're going to look at pH for strong acids and base, and then pH for weak acids and base. Why are we considering them separate? Is because for strong acid or base, they ionize completely. So it means that the concentration of the acid or the pH of the acid is going to be the same thing as the pH of the hydrogen ion, because all the hydrogen ion ionizes. So you can actually use the hydrogen ion to tell the strength of the acid. But for weak acid, you cannot use the hydrogen ion to tell the strength of the acid. Why? Because not all the hydrogen ion from the acid goes into solution. So that's why we need a different way to get that. So pH for an acid, for a strong acid, is just gotten directly by taking the negative logarithm to base 10 of the concentration of hydrogen ion. So that is the formula for finding pH, and it is one of the easiest things you would ever meet in chemistry. So you also have POH, which is negative log to base 10 of hydroxide ion. These are formulas you need to know. You also have the relationship between these two. pH plus POH is equal to what? 14. The total number on the pH scale is 14. You should know that the total number is 14, from 14 to from 0 to 14. There you have 7. 7 is neutral. Anything above here, anything from here above is what? Basic. Anything down is what? Acidic. Alright, that is the pH scale. So that's why the pH plus the POH should always give you what? 14. Of course, this is derived from, you should also know this is actually derived from this. The hydroxide ion concentration times hydrogen ion concentration is 10 to the power minus 14. That is where this thing comes from. So these are formulas you should know under pH calculation. Let me give you 2 examples, because I'm almost done. 2 examples under this, then I'll move to weak acids and base. 2 examples. Say you have, calculate the pH of HCl with concentration of 0.01 molarity. So this is one, and then I'll give you the second one. So calculate the pH of HCl with a concentration of 0.01 molarity. So that's one of the things we want to do. So the pH to know is anytime you're dealing with a monobasic acid, anytime you are dealing with monobasic, that is an acid where hydrogen is only one, it means that the concentration of hydrogen ion there is going to be the same thing as the concentration of the acid. So the hydrogen ion concentration will be the same as concentration of the acid. So with that, you can do your calculation. So my pH is going to be using this formula, minus log to base 10 of 0.01, right? And if you use your calculator, remember calculator is allowed in your Chem 101 exam. Use your calculator to do this. You have 1, 2. So the answer is going to be what? 2. Use your calculator and punch it. Punch minus log 0.01. You don't have to put 10. Your calculator's log is already in base 10. So just punch minus log 0.01. It will give you 2. So, and the shortcut here is that anytime you are dealing with monobasic acids and your numbers are always 0.001, maybe it ends with 1 concentration, it means that for you to get answer, you just write that in standard form. The power is your answer. So what I mean is this, if I want to write this in standard form, it's going to be 1, 2, so which is going to be 1 times 10 to the power minus 2. So what is my answer? My answer is 2. So please, Confirm that the pH is 2 by calculator. Confirm it, please. Confirm it. Confirm it. It's correct, right? Yes. So I want to give you one more. So calculate the pH of a solution of H2SO4 with concentration of 0.02 molarity. With concentration of what? 0.02 molarity. Now, remember pH uses hydrogen ion, right? Yes, so it means you need to get the hydrogen ion concentration. What they gave you is the acid concentration, not the hydrogen ion. So since this is dibasic, anytime it is dibasic, use 2 to multiply. So you're going to have 2 times 0.02. This is going to be what? 0.04. So that is the concentration of hydrogen ion. Then you can now get your pH. What is our pH? Our pH is going to be minus log to base 10 of 0.04. So if you do this, punch this with your calculator, tell me the answer. So I would now move. If they ask you to get, okay, tell me the answer. I'm waiting. All right. Share this video. By the time we end, I want you to share it. Please don't assume that they will come and see it. Help us share it. All right. So what we are doing so that it will go around. Remember, it is energy draining. I'm very tired as I'm standing. It's energy draining. So help me always share like you have always done. Our subscriber base is growing very fast. This is one of the fastest growing channel I have known, right? Yes, with your help. It's one of the fastest. And we are already tending towards 4,000 subscribers. I believe by the time you share this video, before evening, we should have hit 4,000. And I know you'd love to come back and see this channel in 4,000 and even beyond. So help us to share this video once we finish. Keep sharing our videos, keep dropping comments, keep liking. It is by liking, sharing, commenting that YouTube will now start recommending our videos. Like yesterday, we were having a live session. We have people from India joining us, and it is as a result of your likes. When you keep liking this video, it begins to go to different parts of the country. So help us to keep doing this work. What is the answer? What is the answer? Okay, 1.34. Tochi, thank you. Thank you. Now 1.34, 1.39, sorry, okay. So 1.39 is the pH. So that is clear. So let us look at pH for weak acids. pH for weak acid and base. So this is, I will just go straight to the point. If you are dealing with weak acid, you don't just calculate their pH directly. You don't calculate their pH directly. The first thing you want to do is, remember, weak acids, they don't ionize completely. They don't give out all their hydrogen ion into solution. So it means that you will not be able to calculate the concentration of hydrogen ion directly. So for weak acids or base, say you have an acid in this form, this is an acid. If it is a weak acid, what will happen is that it will give an equilibrium reaction because not all the hydrogen ion will be ionized. So what will happen is that, remember, this is aqueous. This will break down to give you H plus A minus. This is what you have. This is aqueous. This is also aqueous, right? Yes. And in order for you to calculate, you need to do what we call, use what we call the ice table. I'm going to teach you ice table under chemical equilibrium, but you don't even need it here. So, but if you follow the ice table, you'll now be able to find what you call Ka. Ka is called acid dissociation constant. Acid dissociation constant. What is acid dissociation constant? It's just like you getting equilibrium constant for an acidic dissociation. That is what it means. So if you want to write the equilibrium constant for this, it's going to be change the concentration of product over concentration of reactant. So this is acid dissociation constant for a weak acid dissociation. This is what you have, right? Yes, they can even give you this question. They will give you maybe ethanoic acid breaks down to give this. They will ask you to find the acid dissociation constant. Remember, this thing is equilibrium. So you are using the equilibrium value of hydrogen ion, equilibrium value of the base, equilibrium value of the acid. That is what you're using to calculate this. But for the sake of your exam, they will not be asking you to calculate this. Yes, I've gone through your lecturer's material, so I'm working with that material. They will not ask you to calculate this. And even when they ask you to calculate this, it will be easy. They will give you a very easy way to do that. So with this, if you want, remember our aim is to calculate pH. For you to be able to calculate pH, you need to know this, which they will always give to you. Once you know this, you find your hydrogen ion concentration from knowing this, from this particular equation. Let me explain so that you don't get confused. I believe I can rub this. If your acid initially has a concentration of, let's say, C, and then over time, initially the concentration of this one is 0, concentration of this is 0 at the initial time. Then when there is a change, what will happen to this one? The concentration of this would now do what? Would now reduce, right? This becomes, let's say, minus X, it decreases. Using minus means that it is decreasing. Then this one will increase by X, this one will increase by X, right? Say this is the new concentration of hydrogen, so it will increase by X. This one is minus because over time, C means change, I means initial concentration, C means change in concentration. So when it is decreasing, you use minus. When it's increasing, you use plus. Now, what will now be the equilibrium concentration? The equilibrium concentration is going to be this plus this, which is C minus X, this plus this, which is X, this plus this, which is what? X, right? Yes. Now, for a weak acid, C is always much greater than X, so that C minus X is approximately equal to C, right? For a weak acid, C is always bigger than X. Remember, X is the hydrogen ion concentration. So if you do your acid dissociation constant, you're going to have your hydrogen ion times this divided by your acid, right? This is how to find Ka. So if you substitute these values that you have, if you substitute these values, you will have that your Ka is going to be, hydrogen ion concentration is X at equilibrium. So it's going to be X times this is what again? X at equilibrium. Then all over this, which is C minus X, but we have known that is approximately equal to what? C. So C. So that when you solve this, you then have X times X is X squared divided by C. So if I make X the subject, remember this Ka equals X squared divided by C. If I make X the subject formula, I would have that X becomes square root of Ka times C. Now what does X represent? X represents hydrogen ion concentration. To always find hydrogen ion concentration, what will you use? You would use root Ka times the concentration of the acid. A is Ka, acid dissociation constant, it will be given to you. C is the concentration of the acid. So you want to now find hydrogen ion concentration, you use this formula. Once you have gotten it, then you now find pH. I will give you an example. Screenshot this. Let me give you an example because we'll draw the curtain here. This is the last part. Screenshot it. Screenshot it. Tell me to move on. Let me give you an example so you understand. Tell me to move on, please, so that we can finish up with an example. Chidebube say I'm tired. That is it. You have this exam tomorrow. Even me that I'm teaching you, I'm also tired. But I'm trying to see how I can cover. I'm trying to see how I can cover for you. Now, in all of these things I've done, please, the major thing you need is just this. So don't stress yourself. You want to find pH of a weak acid. You need to find the hydrogen ion concentration. If you have found this, then to find your pH, you just use this formula, which is what you have known. That is what you do. So these are the two things. Why did we have to go through this stress? Because we know that for weak acids, their hydrogen ion concentration is not the same as the concentration of the acid. So take this example. Find of ethanoic acid with concentration of 0.01 molarity. So this is an example. Find the pH. Now, looking at this ethanoic acid, you don't need a soothsayer to tell you that it is a weak acid. Now, upon knowing that it is a weak acid, it means that you will not go straight to find the pH. The first thing, okay, with concentration of this and Ka equals, let me give you a value, let's say 1.3 times 10 to power, let's say, I don't know a suitable value, let's say -4. Let's hope it will be suitable for us. So this is what they will give you. Of course, even if you don't know that it is a weak acid, once they give you Ka, you should know that the acid they gave you is a weak acid. Now, if before we find the pH, first thing you need to find is hydrogen ion concentration, which is going to be square root of Ka, 1.3 times 10 to the -4, times C. C represents the concentration of the acid, which is what? 0.01. So if you punch this, give me the answer. If you have gotten this, then our pH is going to be minus log to base 10 of our answer. So give me the answer here so that we can finish it. Punch it quickly. Punch it. Punch it. Who has the answer? I'm waiting. Move on. We are done. After this question, I will end. So just give me the answer so that you rest. Oh, it's already 1. We have stayed from 10. It's 3 hours. Nobody has the answer. I mean, they are sleeping. I'm waiting. So 1.4 1.14 times 10 to the power -3. 1.14 times 10 to the power -3. So if you put it here, 1.14 times 10 to the power -3, and you punch, what is the pH now going to be? The pH is going to be 2.85. 2.85. So that's the concept. This same thing I've explained is applicable to base. For base, you talk about Kb. Same idea. If it's a base, you'll be talking of OH minus, which is going to be what? Kb times the concentration of the base. You follow the same process and get your POH. So I'm going to end here. I believe I've done justice to a great extent on acid, base, and salt. What is a salt? A salt is a substance that is obtained from an acid, right? By replacing the hydrogen with a metal. The hydrogen can be completely replaced or partially replaced. So depending on the kind of replacement, it will give you different type of salts that you have. A salt is gotten by replacing the hydrogen in an acid by what? A metal or with a metal, right? That is a salt. You have different types of salt. You have your normal salt, you have your acid salt, you have your basic salt, you have your double salt. Potash alum is an example of double salt. You have your complex salt. These are the different types of salt you have. Now, I believe that this is clear to you. Now, we're going to stop here. Remember that we have a session by 4:15 this evening. We're going to look at some other areas, chemical equilibrium, and then maybe we'll start solving problems. I will draft out questions that we're going to solve in the evening from different topics. So do well to share the link for this class to your friends. Please help me share this to your class group. Share this particular video. Subscribe if you are yet to subscribe. Hit the like button. Tell others about this channel, Prime Concept channel. Tell others about this channel. I'll see you in my next video. Thank you. So somebody said I should make it 5. Is 5 better for all of you? Is 5 is better? Indicate so that we'll know. Is 5 better? Okay, 5 is okay. Okay. Okay, so 5 is okay. So it means our time is going to be by 5. I'll post it. So 5 is okay. All right, thank you. I'll see you by 5 p.m. Thank you. Thank you. Thank you. Thank you. You're welcome, Muchechi. Thank you. Thank you. Thank you. So if you are not in the group, I will post the group link on this video. Then you join the group. All right. Thank you.